the vertically stretched or compressed the original parent functions, make it wider or narrower, and I can explain how to reflect the original parent function over the x-axis.
So, parent functions. We've had them for linear. What's the parent function for linear that we usually think about? Y equals just what? Just x. Absolute value, y equals absolute value of x. Quadratic looks a little different. So, when we are looking at a family of functions, it's a group of functions that have common characteristics, and it's the simplest function within the family of our parent functions. So the quadratic is actually not that different than the other one. Yep, don't work on the homework now. Go to this part, It is going to be the y equals x squared, right? That's just the parent function. You got to write this down for me, please. Thank you. So, family of functions in a group with a common characteristic, simplest function within the family is called our parent one. So, the next screen down is where we are writing our parent functions. And you see a picture of each one of those parent functions. Okay? As we have studied in our different ones, the following parent functions. We are going to write an equation for our parent. So linear is y equals simply x, right? Goes through 0, 0. Y-intercept has a slope of 1. Absolute value is absolute value of x. Has a slope of 1, has a slope of -1. Vertex is at 0, 0. Quadratic is x squared. Vertex 0, 0. Plug in 1. Get 1 squared is 1. Plug in 2, I get 4. This is my normal width. Same with this one, the normal width when we talk about that. So now at the top of the next page, we're going to do some transformations. So we are transforming our function. It says add 3 to each parent function and graph it, then add -2 to each parent function. So the first one, when you add 3, what does that do to it? Moves it up 3, right? So we go up 3. Does the slope change? No. So we're going to get all those points, right? So I'm going to do the +3, and I'm going to do that in pink for each of these. Okay. Going off here. So if we are drawing that function, I want you to first do each of these in going +3 on each one. So besides knowing the y-intercept is 3, I also noticed that the x-intercept is -3, right? Okay. So now I'm going to do my next function, which was to add 3. So that moves it up 3. My slope doesn't change, right? And when I do my quadratic with +3, some of you are struggling with how do I find the vertex when it's +3? These are the easy ones, right? You just go 0 and then it is +3. So it's that same curve going to one, same width that we are looking at. So now we want to do adding -2. So let's go through this time. So -2. So if I have y equals x minus 2 or plus a -2, this one is going to be absolute value of x minus 2. And our last one we are going to be looking at is x squared minus 2. So again, we are moving it down 2 on our y-intercept, but our x-intercept is at the opposite of -2, which is positive 2. Okay. Here we are moving it down to -2. And we are keeping that same slope of 1. And here we are moving it down to -2. And we're going to have this point at 1. And if we go over 2, 1, 2, 3, 4. Same width as we look at that one. So when I'm looking at each of these functions, and as I look at graphing the other ones, I'm going to try and get straight lines for you. So I'm going to have my slope of 1 here. Oh, let's change the color. So I still notice that when I look at these, that where that vertex is, and as we look at this one, so not only are we looking at the y-intercept, but the x-intercept as we look at these. And as I'm looking at describing how adding that number will change a function, this is what I want you to keep in mind. It moves the function, when we go outside, it moves it up or down, okay, on the y-axis. So anytime we are adding something and it is, if we are thinking of that like outside of that function, it's going to move it up or down. This moves it up and down, up and down. So now we're going to go on the next page. We're going to go within the parentheses. We're going to look, how does it change within the parentheses? So this is going to move it up and down. As you look at the next page. Now we want to transform it, but this time we're going to do that same addition of 3 and subtraction of 3, but it's going to be inside the, when we are looking at that, inside of our parentheses. So we're going to think of this as x plus 3. Then we're going to do a function where we are going to have, so the first time we want to add 3 to each one. And the next time we want to think about it, and we want to, this time instead of adding 3, we want to subtract 2. But again, we want it to be parenthesis x minus 2, absolute value of x minus 2, and we want to go parenthesis x minus 2 squared. Now, does it change these in the linear at all, or do they look exactly the same? X plus 3, is that going to change it? That means to go up 3, right? If you're graphing that, right? If I'm graphing the plus 3, doesn't that still mean I'm going to go here? And if I'm doing minus 2, I'm still going to go down here. So draw that one first, okay? So if we are thinking about that one, then we draw our 2 lines, okay? That one stays exactly the same, right? This one is going to stay okay. So when we look at those two, what I want to decide is, as I look at those lines, before we said when I was outside the parenthesis, it moved it up and down, but now we're kind of concentrating on this point and this point. So when it was plus 3, we actually moved it. We want to think of where it changes, okay? So what's going to happen with plus 3 when it's inside? Anyone remember what that plus 3 does? It's kind of like our vertex form we were looking at. Yep. So we're going to go, so you're going to do the second one. So the plus 3, Kylie, which way are we moving it? Over here, 3. Okay, so if I plug in 0 for x, right? So if I say x is 0, and maybe let's just try this number of 3. If I plug in 3, absolute value of 3 plus 3, does it give me y equals 0? If I plug in 3, it gives me 6, right? Oh, so which way should I be going when it's plus 3? If I want it to be on this line, right, it's going to be left 3. And if I think of plugging in, this is when x equals, right, -3. -3 plus 3 gives us 0. That's this point. If I plug in -2, -2 plus 3, absolute value of that is going to give me 1, right? X is -2. When I plug in x is -1, -1 plus 3 is going to give me 2, positive 2 in the absolute value of that. If I plug in -4, -4 plus 3 is 1, -1, absolute value. So if you are not sure, plug in the next value, right? If you're not sure that it's working. So Caden, you were thinking when we did the -2, what's going to happen there? So because it's -2, remember, that's kind of that vertex form that we were looking at. It's going to move it 2 to the right. And if I plug in +2, +2 minus 2 is 0, that is this point. we're trying to see when our y value is 0, right? If I plug in 1, I'm going to get -1. Absolute value of -1 is 1. And so we should have our V shape moves left or right, right? Looking at that number. So does that help us with our parabola? Someone want to tell me how I'm going to move my parabola? The +3 is going to do what for me? Which way should I be moving it? +3. Similar, right? Left 3. Left 3. Same shape, right? 1, and then here it's going to be up to here 4. This is going to be that shape, same shape that I'm looking at with +3. And then my -2, if I'm looking at that one, okay,
To the right too.
can go to the right too. In the same shape, because we haven't done anything with our width, our A value is still 1, right? So thinking about that, whereas the left one, the last thing when we had outside the parenthesis, it moved it up and down. Now when it's in the parenthesis, it's moving it, how would we want to say? It's moving it left and right, right? It's going to move it to the left or to the right. So, and you got to be really careful for this last part, right? When we are looking at which way is it going to move it, positive moves to the left, negative to the right. It's the opposite of what we are thinking when we look at this, okay? It's always on the x-axis is how it moves it. Whereas when we looked at our last one, when it's outside the parenthesis, it's always on the y-axis. So outside the parenthesis, y-axis. Inside the parenthesis is looking always at our x-axis, okay? So make sure you have that last part down. That's the A value or our slope when it's in our function. So we want to be thinking, okay, what happens when we go first? F of x equals 3x, and then we're going to go with f of x equals 3 times absolute value of x and 3 times x squared, okay? The next thing we want to take a look at is what's going to happen when we are multiplying by 0.5. So we're going to do 0.5 in green. So we'll go equals 0.5x equals 0.5 times absolute value of x squared. And then we have one more this time. Then they ask us to also look at multiply everything by -1. So we're going to have a third one, which will be f of x equals -1x, right? F of x. Why are we doing f and not y equals? Anyone? Why we're doing f? These are all what? All functions. F of x, a function. F of x, I know, isn't that weird? F of x equals -1 and x squared. Okay? So all functions, right? Functions, each input has one output, right? So the first one, let's do that one. Slope of 3, does it always go through 0, 0? Is that changing at all?
No.
No. All of these are going to say that same vertex, right? They just get narrower and wider, right? So if you have not graphed your first one, please do that with a slope of 1/2, right? That means a rise of 1, run of 2, right? Slope of 3 means rise of 3 over 1. 1/2 or 0.5 means rise of 1 over 2, rise of 1 over 2. F of x equals -x means my slope still goes through 0, 0, but now it is slanted, instead of going up, it's going to be slanted going down, right? So when I look at my graphs, I'm showing all 3 of those for you. When I look at those, I am looking at, this is my 3x, right? This is my 0.5x equation, and this was my -1x. What's going to happen to -1x for the V shape? It's going to be the same thing, but it's going to go down, right? It's going to be like this, points going here, here, going down, right? What's going to happen to the 3? That means you have a slope of 3 up 3 and over 1, right? Up 3 and over 1. draw in that V. And if it's 1/2, it's up 1 over 2, up 1 over 2, right? So as I'm looking at those points, I want to draw all my different V's. So when I'm looking at those, if we go back to our colors, this would be our pink one, right? This would be our green one. Okay. And if we were looking at ours with the negative one, okay. So as you are looking at those different ones. Okay. So last one. Vertex is the same, right? The negative should be almost like our absolute value, right? When I plug in 1 now, 1 squared times 3, at 1 I'm going to get 3. At 2 I'm going to get 4, right? Times 3, which would be at 12. So it makes it much narrower if I'm looking at it. 1/2 means that when I plug in 1 squared times 1/2, I'm going to get 1/2. If I plug in 2 squared is 4, 4 times 1/2. Going, right? So it's making it much wider. And then the negative is going to make it go down. We'll get a fair nice drawing. Hopefully it's a nice and accurate up there. And if not, that's all right. Okay, so looking at those points as you look at those. And then the question asks again, as you look at this, describe how that number outside, the A value, what does that change your slope? And this is where we are talking about whether it compresses it or stretches it. So when we think of a stretch, right, stretch is getting wider. Stretch, if, in their case, when they think of that stretch, they're thinking of it getting like a narrower one is what they want. It stretches it up more, and compressing it is like you're flattening it out. So that's how they're thinking about it. So that's our fractions and our decimals, and negative reflects it down. Okay? So what we're going to be starting with today is I'm going to give you all 3 parent functions, and then I'm going to say something like these different things for each one, and you're going to be asked to write the new equation. Now, if you have your device with you, your computer, one thing I would recommend as you're looking at these, just to make sure you're checking, is you can put the equation in the decimals calculator, right, and you can check it. You shouldn't have a problem with the linear. But some of you kind of might be getting mixed up with these, but you want to come up with it first and then change it. So now it says, okay, here's the equations. Graph the transformation. So inside the parenthesis with +3 tells us to move which way? Inside tells us, if we're going inside the parenthesis, that tells us to move left and right, right? So if you're inside your parenthesis, that's always telling us left and right, right? If we go outside, that tells us to move up and down. Now, in linear, does it really matter that much? No, but it's kind of telling us move the vertex over which way when it's +3. So positive is to the left, right? Negative is to the right. But here, positive is up, down. So please graph that first one for me. I'm going to wait for you. You really could have just gone up 4, but what that 3 was telling us was move 3 to the left and then up 1 by the number outside. So that's where our new vertex is. Now that is going to help you as you do absolute value. Because absolute value, where are they telling us to move the vertex to? 3 to the left and up 1. Should it be the same slope of 1 and -1? Definitely. Okay. Last one. Where's our new vertex going to be? -3, 1. So as you look at those, the shapes will always kind of be the same then, as we look at them. It's moving the vertex. Today when you do your homework, that's what you kind of want to be thinking of, is what they are telling you as we move that. Okay? questions? The last one has some multiplying, and we are moving the vertex. Okay? So, if you have not started that last one, get your vertex point first. Okay? And you look at the top of the next page. Just make sure you change the picture. So, some of you, I was noticing that, right? So some of yours are going to be in the homework. We'll have a positive number, some will have a negative number. Most of these notes are online because really there wasn't much to change from last year. So first thing, if I'm looking at this, where is my vertex? Raise your hand with it being -1 minus 3. Kind of. +1, and then we are going down to -3. Put that point on your graph now, everybody. Is it the same vertex for every single one? Yes. That's like my start point. So I'm going to go again. +1, -3. +1, -3. But now I have to deal with the 2. 2 deals with the what of the line in question 1? The slope, right? It makes it steeper, right? We are now going to go up 2 and over 1. That means the slope of our v is not going to be 1 and -1. It's going to be 2 and -2. Okay? My parabola, we want to be thinking of how that one's going to be changing also. So here is your new graph of each of those. Hopefully yours was very close to those, being much narrower. And I just kind of want you to notice that we kind of tried to put the points, like, so there's a point, there's a point. If we're looking, you kind of think if that's where that one is. We'll go here. This one is going to be way up here. So if you go over 1, should have gone up 2. If you look at that. Questions. Parent function is, and I don't care if you want to, and let's use the same notation they did instead of y, f of x equals x, right? Parent function for absolute value is y equals absolute value of x, and quadratic is y, not y, f of x. Okay. So, answers, I don't think the answers are in the back of this one. No. So we'll take a look at this in class tomorrow when we're in. And